To show you what happened on the radar earlier today over Oklahoma and North Texas and Kansas. So let's just go back. We're going to look at the mosaic radar first, but I think even the untrained eye will be able to see in about 2 seconds here what's going on. Just wait. Okay there, alright. Sorry, I had to unplug my microphone really quick, but maybe I should zoom it in a little. Maybe that'll help you see. Let's go zoom in on the Oklahoma, Kansas, Texas area. Now where you're going to see are storms flare up, of course, but what I'd want you to do is pay attention to what's going through the storms. Watch this. There we go. All right, this is where we flared up into major tornadic activity. We've got multiple tornadoes breaking out across this area, going up into South Missouri. Tornado warnings took place right around this time. Okay, but what I want to draw your attention to is the rotating radar, and what's going on here isn't normally seen by the public. And what they do is they'll remove these off the feed so that the general public does not see this. They call this quality control, to get the different non-weather related signals and reflections off the radar. So you can't see this if you go check your local radar. They remove this. Okay, now what's causing these? Well, we could just trace this beam down here back to its transmitter all the way over at Little Rock. What they're doing with the transmitter at Little Rock is they're actually using a high-power microwave pulsed in a very tight beam of high-power microwaves that goes up at an angle. So this is coming from ground level. You actually have to imagine this going up like a cone into the sky. And they're looking up through the center of the storm and trying to see what's going on inside the storm, the high-power microwave. But it's leaving that signal. Now, that's the beam going through all the way out to the edge of very far out, way beyond what they show the public that the radar goes to. They'll show you 50 and 100 nautical miles around the radar and tell you that's how far it can see. That's a load of crap. It can actually see out 500 miles over to the west and beyond, all the way out to the next radar station over to central Oklahoma. And they can even use one beam to cross with the other. Why would you want to cross one beam with the other? Well, they will tell you it doesn't do anything. But if we listen to Lieutenant Colonel Thomas Bearden's lectures on the topic on where you cross the beams, you can get what they called action at a distance back in the 80s when developing the missile defense systems. And guess what was developed as part of the missile defense program? The WSR-88D, well, at WSR-88 at the time, which is the weather surveillance radar, rolled out as part of the National Strategic Missile Defense Initiative, but paid for by the National Weather Service. And guess who maintains the radars? The military, the U.S. Army and the U.S. Air Force both maintain the radars. U.S. Army goes to the civilian locations if they need anything fully replaced. Now, the real interesting thing about this is where the beams cross, we get action at a distance, according to Lieutenant Colonel Thomas Bearden and scalar. And scalar is just a complex word to describe where two beams cross, an area. It's just an area, but they do scalar Higgs boson experiments, crossing high-power microwaves at CERN over in Switzerland, using banks of klystrons, which are these things that zap up power into more power. They take basically a small amount of power and zap it up in a klystron in a tube. It's an actual gaseous tube, and it spits out more power. It's not over unity. It takes a fair amount of power to go into it, and it's a very complex, dangerous device. But anyway, the klystrons are set up in whole banks at CERN, and they use the klystrons to produce huge power microwave that then they shoot particles with. Well, they produce 2 microwave beams, not 1. And they collide the beams inside of a magnetic chamber to contain the explosions of the colliding particles. Anyway, the collision area is called a scalar, and that's why it's called scalar Higgs boson experiments at CERN, where the 2 beams cross. Ghostbusters, sort of, where you talk about the 2 beams crossing, don't cross the beams. Okay, particle collision, full particle reversal, as Egon tells you in the movie Ghostbusters. How ironic, right? How could I even know it? Now, looking at back at that 1980s too, right? Okay. So the beams crossing We have a beam here coming from Oklahoma, crossing with the beam here coming out of Little Rock, and they both meet right inside the storm. Now, if you go and look at the timing on the storm, you will see the storm starts to take a rotation where the two beams begin, and that's where the tornado warning was issued. Is it chance or coincidence? Maybe they are just looking at the storm, but when you start seeing a rotation on the radar, and this signature in particular in the storms itself, and that the storms take this shape, and that the storms form in this spacing, you start to realize that the storms are being influenced by the radar themselves, and it's not unintentional. It can't be at this point. The storms are forming in the shape of the actual, this, for instance, right there. Now that just refreshed. Just want people to be aware of that. So why am I taking the time to show you all of that? All of that happened over here just a few hours ago. Several of the stations beaming into the spot coming out of Texas. Now, down in Texas, right down here, we get our new earthquake. 5.0 downgraded to 4.3, just beyond the view down here to the south. So I'm going to rewind it one more time. And we're just going to see what comes out of Texas again. There we go. So, coming out of Texas down to the south. Well, first of all, we have a few things beaming into Texas. That's pretty interesting, isn't it? But right out of there, so coming out of Texas down to the south, meme here. Another down to the south. Now this one is beaming from the north all the way up in Kansas, across all of Oklahoma, and the beam's going up above North Texas. Trace it all the way back to the station here. That's how far the station really beams out. Same within North Texas again. Down to the south now, it looks like we got a station down here in Texas doing it. And then right about there, it looks like down. Wow. This is now getting to just maybe a couple of hours before the earthquake down in Texas. I'd like to go down and just quickly look at the state of Texas as a whole and just see if there's anything else showing up, aside from a big line of storms, of course. Wow, okay. You see them beaming in from the north. That's supposedly just being absorbed by the Earth's electromagnetic field as it dissipates out into the atmosphere. You know, captured by the Earth's magnetic field. You know what happens when that happens? Goes down to ground. Okay, so looks like they're hitting the storm right there. They're looking at it. This station over here in West Texas, beaming across to right here, looking into the storm. But pre-storm, there's nothing there, right? No storm yet. They're looking into it, and right where they're zapping, boom, that's where it forms. Look at that. They zap it a few times first. Zap, 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 boom. Then it takes off, right? Okay, where did they zap? Right here. They zap it, it forms. Zapping first. Again, there's nothing there. This is over the course of hours. Look, they got a park there. Park, 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 and then just so happens that that's where the storm forms a couple hours later. Please, right? High-powered microwave targeted an area over for hours into a dust storm or whatever that is, a front coming across, and then boom, that's where it breaks out. You got to be kidding me, right? That's not chance. But let's go compare to where the earthquake struck. Should be pretty easy to find. Earthquake struck right here. Let's get the coordinates from the USGS. Hermleigh, Texas. South by southeast of Lubbock. West by northwest of Abilene. Do we have any kind of county lines or something that we could put on here? Street map? Roads will do it. Okay, the roads will do it because I can go over here and turn on, I think... Do we have roads on here? Okay, look. The earthquake is striking right up in here. It definitely is. The earthquake, it's within 50 miles. Guys, the earthquake is within 50 miles of it. Again, an earthquake right up here, or 100 miles. That might be 100 miles. Still, it's so close. It is. It is so close. I'm glad I went to go compare. So the earthquake is striking right in here. The beam that formed that started this whole southern part of this storm here, boom, breaks off into a huge outbreak that goes across and over to the east where we are now. I mean, it could be chance. I'll say it. Could be chance. Chance. Yeah, that's the ticket. It's chance, Dutch. It's just chance that they're beaming there all day and then a storm forms there first. An earthquake striking next to it, too. Wonderful stuff. Anyway, I said I was going to wait till the end of the broadcast to show that to you because we get into how can a high-power microwave or any other kind of directed energy from radio waves induce earthquake activity. Well, there is a technical explanation that I'd give you, but no professional will agree, I don't think, except for maybe Lieutenant Colonel Thomas Bearden, who's now dead, that there's a stripping of electrons that happens, and that Earth's magnetic field does absorb that free-floating radio wave that's alternating current, by the way, AC floating through the air, and it gets captured by Earth's magnetic field as it dissipates out into the ether, and it gets taken back down to ground. And those free-moving electrons through the air, the radio wave and AC, Mother Nature reconverts that to DC down into the plate. It's called efficiency scaling. It's a process that happens between radio waves and the Earth's magnetic field. It's how the Earth's magnetic field absorbs radio waves. They convert into DC power and go down to the core of the Earth, or down to ground, which is the plate. And then you get earthquakes down below areas where you've stripped a bunch of electrons by scuffing your feet across the carpet of the atmosphere. The radio waves are scuffing their feet across the carpet of the atmosphere at that spot all day, which then induces cloud condensation nuclei up in the sky, the thing that precursor to rain. Normally dust would attract water molecules in the air, but that can also happen when you strip electrons, ionization, up in the sky. Already proved. These things are already proved. Cloud condensation nuclei done by the American Meteorological Society in experiments down in Laredo, Texas, using straight-up electricity through wires spread out across a couple acres and a big generator. Anyway, just giving you examples, guys. I just got on to do this update I can't sleep. So, this update is just solely because I'm having a bad week on all kinds of stuff. It just hasn't been